Okay, so I'm just going to go over the answers to this formative quickly so that you guys can understand these things before you take your test. Three types of transformations that are isometries are reflections, rotations, and translations. And that's because in all three of these cases, when the transformation happens, the preimage stays congruent. I'm sorry, stays congruent to the image. In other words, the size doesn't change in an isometry or a rigid motion. These transformations, this is a point right here. This rotates, spins on this point, so that's a rotation. This, it doesn't, we don't know which one's the preimage and which one's the image, but clearly one is bigger than the other one. So this is a dilation. We don't know if it's enlargement or reduction because we don't know which one came first, but they're both considered dilations. This is just sliding over, so it's a translation. Okay, the type of transformation that would result from the given rules, and then I said be specific. What I meant by that is to tell me more about it rather than just the type. Tell me more about the specifics of the transformation. So this one you should be able to recognize anytime they're adding or subtracting the x and y. It's a translation. So that's the type of transformation. More specifically, it's a translation where the object is going to move to the right 4, right or left is on the x-axis, right? And down 8, because when we change the y by subtracting 8, it moves it down. Here, you should be able to tell just by looking at it that when you multiply all the x's and y's, you get a dilation. That's the type of transformation. More specifically, this particular dilation is an enlargement because the scale factor is 2. Anything greater than 1 will make a figure get bigger, so it's called an enlargement. If it was a fraction between 0 and 1, it would have been a reduction. Okay, in the diagram, the dashed line is the preimage. So that means it starts big, starts as dashed, and becomes small. Starts big, becomes small, that's reduction. Now, remember the scale factor is new over old. Well, if we look at how it started as this big triangle, this side was 11 units long. So it started at 11, that's the old. It shrunk down and became 7. So your scale factor should be 7/11ths. Which makes sense that it's a reduction because 7/11ths is a fraction between 0 and 1. The top number is smaller than the bottom number. Okay, when triangle ABC is dilated by a scale factor of 3, its image is A prime, B prime, C prime. True or false? A, B, so the side AB is congruent to the new side, A prime, B prime. That's true. I'm sorry, that's false. Because when we dilate, that is going to make everything 3 times as big. So the side should be 3 times longer. So it's not going to be congruent. It's going to be 3 times longer. So that's a false statement. Angle A is congruent to angle A prime. That's true because when you make things get longer in the sides, this angle measures still stay the same. Think about a right angle. Right triangle. Now I make a bigger right triangle. Right? It's still 90 degrees. The angles stay the same. So this is true. 3 times the perimeter of ABC equals the perimeter of A prime, B prime, C prime. That's true. If all sides got 3 times longer, then the perimeter would be 3 times longer as well. The area, however, gets more than 3 times bigger. So this is false. Okay, use coordinate geometry. When you are doing this on the test, you must show all calculations. You have to show all the work. So for this one, we're trying to figure out if it's scalene, equilateral, or isosceles. That means we need the lengths of the sides. We need the distance formula 3 times. You have to do and show all the work because you're finding the length of each side. So we're going to find the length of SU, the length of UN, and the length of SN. Remember the distance formula, subtract the x's. So for SU, we're going to do a negative 1 minus a negative 2 squared plus 0 minus 4 squared. For UN, x is first, we're going to do 2 minus negative 1 squared and 5 minus 0 squared. And then for SN, 2 minus a negative 2 squared and 5 minus 4 squared. When we do this out, negative 1 minus a negative, that's plus a positive. Negative 1 plus 2 is 1. Squared is 1. Negative 4 squared is 16. So this is the square root of 1 plus 16, or the square root of 17. 2 minus a negative 1 plus a positive, that's 3 squared, plus 5, is that a 5? 5 minus 0 is 5 squared. So we've got the square root of 9. 3 squared is 9, plus 5 squared is 25. Square root of 34. Sn, 2 minus a negative is plus a positive again. So that's 4 squared. 5 minus 4 is 1 squared. Again, we have 16 plus 1, square root of 17. So these two turn out the same, which means two sides are the same, so we would call this isosceles. So lengths of sides to determine scalene equilateral isosceles. Remember, the other thing you need to know how to do is determine if a triangle is a right triangle. And for that, you would use slope formula and look for opposite reciprocals or 0 and undefined. Either case would get you perpendicular lines, which makes it a right triangle. If there's no opposite reciprocals, there's no perpendiculars, then that would make it not a right triangle. Okay, good luck.